Good day, my name is Carolyn Hugo. I am currently a first year in chemical engineering and this is my homemade Viscometer project. This video presents the fabrication and testing of a simple homemade Viscometer for the measurement of Newtonian fluids. A fluid's resistance to flow due to internal friction causes a large shear force requirement to move one layer of the fluid in relation to another. Viscosity is the ratio between the shear force and the resulting distortion of the fluid. 3 different Viscometer designs were built out of recycled materials. The funnel Viscometer and the sliding surface Viscometer in this clip and the previous one were not sufficient designs as the mathematical models of viscosity could not be achieved. The final design is a falling ball Viscometer. As the ball travels through the liquid, it experiences 3 forces: frictional force, buoyant force, and gravitational force. The sum of the frictional and buoyant forces is equal to the gravitational force that the Earth exerts on the ball when the forces are in equilibrium. The resulting equation can be derived. This shows the final optimized design of this Viscometer, which allowed for minimal fluid usage and distance to reach terminal velocity. This design still had numerous issues, one of them being surface tension of the fluids, causing the filling of the pipe to be strenuous. The final design was calibrated by dropping a bead into water in the cylinder and recording the time taken for the bead to travel 0.3 meters near the bottom of the cylinder. This process was then repeated using canola oil and motor oil respectively, and then repeated with water at different temperatures to establish the relationship between viscosity and water. The results were as displayed. The results should be divided by 43.97 as a calibration factor. The homemade Viscometer is highly inaccurate. The percentage error between the experimental and theoretical values is on average 4,297.11%. The proposed relationship indicates that as temperature increases, viscosity also does so. The theoretical relationship states that in liquids the viscosity decreases with increasing temperature due to the increased spacing between the molecules. Therefore, there is error in the timekeeping as well as the temperature recording. A controlled environment, cleaning in between and repeated calibration will eliminate errors and make a promising solution.